I think we could make a lot of progress in improving science education simply by taking advantage of what's known about learning and learning science and proper measurements of student learning. I think there's been tremendous progress over the last couple of decades in cognitive science, educational psychology, about how people learn. And then there's also been a lot of equivalent progress and closely connected work in what works in the university physics classroom in particular, and other disciplines, because it's one thing to know in general how the brain learns. It's another to understand how that plays out in what I should be doing in junior year of electricity and magnetism. So one has to bring together a lot of knowledge and assemble it and utilize it. That's really what my efforts these days are about, is trying to find an institutional way to make that happen, because I don't think we need tremendous breakthroughs in understanding. It's kind of, if you think about a product development stage, the fundamental research has been done. We know what to do. We now have to carry out the development of turning it into a polished product that produces, leads to highly educated students. But it's not easy. One thing I've come to appreciate is thinking scientifically is not a natural condition for the human mind. I see routinely scientists who, have very strict ways of thinking in their discipline. As soon as they move out of it, start talking about teaching, they become, trying to think of some charitable way to describe this, but they fall back on superstition and tradition and things that they would totally dismiss if they heard anyone using that same kind of rationale in a discussion about the science. But in 30 seconds they can switch to that way of thinking. So I've come to appreciate this is not an easy problem. It's not all that natural for people to think about anything, whether it's physics phenomena or education, in this kind of rigorous scientific way.